Hello friends, today we'll solve the year 2024 signals and system problem of electronics paper. Okay. So this is the first question. For a causal discrete time LTI system with transfer function as z is equal to 2z square plus 3z plus 1 by 3 z minus 1 by 3, which of the following is true? System stable or not, minimum phase or not, initial value, final value. Okay, so let's first start with minimum phase or not. So for minimum phase, we know that all pole and zero should be strictly in the left half of S plane. Okay, if we talk about S plane, and it means inside the unity circle in Z plane. Okay, because inside the unity circle means left half, outside the unity circle means right half of S plane, and this j omega axis in S plane means this unity circle in Z plane. Okay, so this is the normal standard mapping between Laplace transform and Z transform. So we need to find location of pole and zero. So pole are inside the unity circle clearly, because one is at minus 1 by 3, one is at 1 by 3. So these are inside the unity circle. Okay, but zeros, if we see, then this is like 2z square is equal to minus 3. So z square is minus 3 by 2. So z is plus minus under root minus 3 by 2. So which is plus minus j under root 3 by 2. So which is plus minus j 1.22. So these are like outside the unity circle. So it is not a minimum phase system. Stability. So stability, we know that it depends only on pole location, and it is given that the system is LTA and causal. So for causal system, ROC must is outside the outermost pole. Okay, so these are the two poles. So ROC is outside the outermost pole, and for stability, ROC must include the unity circle. So this is the unity circle. Okay, 1j minus 1 and minus j. So clearly ROC is including the unity circle, so the system is stable. Initial value of the impulse response. So we'll apply initial value theorem. So S0 is limit z tending to infinity sz. Okay. So which is limit z tending to infinity, and we know sz is this thing. So this will be like, we'll take z square common, zz here common. So these will cancel out, and so this will 0, this will become 0, this will 0. So this will be 2 divided by 1 into 1. So 2, which is true. And fourth is final value is 0, final value of impulse response. So by final value theorem, h infinity is limit z tending to 1, z minus 1 into sz. So there is this z minus 1, and here there is this hz. Now you can see that this z minus 1 will not cancel with any of the pole. Okay, so and when we put z is equal to 1, so this will be 0. 1 minus 1 is 0, so 0 into anything is 0. So yes, D is also correct. Okay, so this is also true, this is also true. So A, C and D are correct. Second question is on Fourier transform. It is saying that consider the continuous time signal xt and yt is shown in figure. This is xt, this is yt. If xf is the Fourier transform of xt, then Fourier transform yt is. So we need to find Fourier transform of this thing in terms of this function. So first let's convert it into this form. So you can see that first we need to do amplitude reversal. Okay, so that it will become like this. Okay, and then we need to scale it by 4. So this one will become minus 1 will become minus 4, and then we need to shift right by 2 so that it can become minus 2 to 2. Okay, so amplitude reversal is there, scaling is there, and time shifting is there. Okay, so time expansion by 4 times. Okay, so this means frequency compression by 4 times. So xt by 4 is there, so 4 times x4f will be there. Here I am using this. If xt has Fourier transform xf, then x of alpha t has by scaling property 1 upon mod alpha x of f by alpha. So here alpha is 1 by 4, so 1 upon 1 by 4 is 4, and here it will be 4x. So this factor will come. Shifting by 2 unit to right means xt minus 2, so that will be equal to nothing but xf e raised to power minus j omega 2. Omega is 2 pi f, so this will be xf e की power minus j 4 pi f. Okay, so these things will come, and minus for time reversal, so minus, and then 4x 4f e raised to power minus j 4 pi f will come. Okay, so this is the correct answer. Or another way is like you can do xt then x alpha t then x of alpha t minus t naught, because it is shifted and scaled version. Okay, so scaling is by 1 by 4, shift and time shifting is by 2. So yt will be what? Minus x of 1 by 4 t minus 2. Okay, so yt is nothing but minus of minus because amplitude reversal, and minus 1 by 4 t minus 2. So it Fourier transform yf will be minus 1 upon mod of 1 by 4 x f of 1 by 4, and then it will be e to power minus j 2 pi f, and then t naught is 2. So again we are getting the same thing. Okay. So this was the second question, Fourier transform. Third question is on continuous time convolution properties. It is saying that if xt, a causal and stable LTI system with impulse response st produce output yt, xt is producing output yt for input signal xt, then signal x of 0.5 t is applied to another causal and stable LTI system with impulse response h 0.5 t, resulting signal is. So here we know this x of alpha t convolution h of alpha t is nothing but y of alpha t times 1 upon mod alpha. So x of 0.5 t convolution h of 0.5 t will be 1 upon mod of 0.5, which is 1 upon 1 by 2, which is 2. So 2 times y 0.5 t. So A will be correct answer. Okay. So simple property of continuous time convolution based question. This is on Fourier transform. This discrete Fourier transform. It is saying that the relation between an n-length sequence xn and its corresponding endpoint dft xk is defined as xk is f of xn. Another sequence yn is formed as like 4 times we have taken the this discrete Fourier transform. So for the sequence xn 1 2 1 3, the value of y0 is. So we need to take first 4 times this discrete Fourier transform of xn. So when we apply 4 times dft of xn, then yn is n square times xn. Okay. So yn will be what? 4 square, because this is 4 point dft, and then it is xn. Xn is 1213, so 16 times 1213. So yn is basically 1632, 1648. Okay. And now he is asking about y0. So y0 is nothing but area under the signal yn, so which is sum of all the values of yn. So we just add these values. So this is 112. So correct answer is 112. So you know that 2 times dft of xn is n times x of minus n. Now again we take 2 times dft. So this by duality we are getting. Then it will be n times of this thing, which is n into x of minus n, so which is xn. So basically we are getting n square xn. Okay, so 2 times dft means x, n times x of minus n, and 4 times dft means n square x of n. So these two results are very important, asked multiple times in GATE. Okay. Another question is on like discrete time periodic signal. It is saying that the radiant frequency value for which the discrete time sinusoidal signal xt is equal to a cos omega n plus pi by 3 has a period of 40 is an r. Okay. So here I will say that a discrete time signal is periodic if the ratio 2 pi by omega is rational. So here we can say that in first option it is 2 pi by 0.15 pi. Okay, it is 0.15 pi. Okay, so when we solve it we get it as 40 by 3. So 40 by 3 is rational, so it is periodic. Now the fundamental time period n will be 40 by 3 into the smallest integer value of k, which make this thing 40. So for k equal to 3 we are getting n is equal to 40. So yes, it is, this omega is valid. Okay, this radiant frequency is valid because for it we are getting n is equal to 40. Now b is 0.025. So for 0.225 we are getting this as 2000 upon 225, which is 80 upon 9. So n is equal to 80 upon 9 into, so for k is equal to 9 we are getting n is equal to 80, but our fundamental time period should be 40, so this will be cut. Now for c it is 0.3 pi. For 0.3 pi you can get it as 2 pi upon 0.3 pi is 20 by 3. So it's a rational, so it's periodic, but n the fundamental time period is 20 by 3 into that value of k, which makes it so here for k is equal to 3 this will cancel, but n will be 20. Okay, so although the time period he has asked is 40, but n is equal to 20 can also be a fundamental, can also be time period, because if a signal is repeating after 20 samples, then it will also repeat by after 40 samples. So this is also valid. in final answer key they have treated it as also the answer. And d is 0.45 pi. So for 0.45 we are getting 2 pi by omega is 200 upon 45, so 40 by 9. So this is periodic, and for n is equal to the fundamental time period of 40 by 9 to that value of k, which cancel this. So for k is equal to 9 we are getting n is equal to 40. So this is also true, this is also true, this cannot be true, and this is also valid, although not fundamental, but still the fundamental time period is 20, but still the time period will be 40 is also valid. Okay, so these were the 5 questions. Sixth question is like difficult, and it is based on sampler plus filtering, so I will discuss it in a separate video. So these were the 5 questions. Thank you.